Hey class, this is Miss Woodleaf. I am going to get you started today on our first lesson, and we're going to start and talk about power of 10 with negative exponents. So we're going to go through some Google Slides for a few minutes. We're going to work through some problems, and then you guys will have your homework to work on. And so we're going to start with our slides first. All right, so we have the power of 10 with negative exponents. Now, today we're going to start to learn about negative exponents, but before we start, we need to review some basic exponent review problems. Now, a product or repeated factors can be expressed as a power. This is using an exponent and a base. Let's look at what these words mean. If we've forgotten, product means we're going to be multiplying numbers together. Factors is the numbers that are being multiplied. So in this example here, we have 4, which is a factor, and we also have another 4, which is a factor. So 4 is my factor in this case that is being multiplied. When we talk about the word exponent, when we see this, usually you have a big number, and then you have a little superscript of a number, which is a smaller number to the top right. Go back. I hit the wrong button. Sorry about that, guys. So my exponent here is the 3, which is the small number to the top right. Then we have the base. The base number is the big number that I have written, so that is 2. Now, when you talk about exponent, the 2 is the number that's going to be multiplied, okay, the number of times the exponent is. Now, there's a couple of special rules. One of them is when you have a power of 1, any number, any non-zero number or variable, and variable, remember, is a letter in place of an unknown number. So any non-zero number or variable to the power 1 is always the number or the variable. So if I have 2 to the first power, that just says I have 1, 2 being multiplied, but you can't multiply 2 by nothing, so it would be 2. So my answer there would be 2. If you have 4 to the first power, then it tells you only have 1 4, so therefore your answer is 4. Now we have another special case, and that is the 0 power. Any non-zero number or variable to the power of 0 is always 1. Okay, so if I have 5 to the 0 power, then my answer is going to be 1. Now let's kind of look at this, okay? So when you have 2 to the third power, okay, we typically would have 2 times 2 times 2 because I'm going to multiply 2, the base number, 3 times. Now, I get 8 with that. Now, I can multiply that by 1, and it does not change my value. So when I really have this looks like 1 times 2 to the third. And so hold on, I've moved forward on my slides. I apologize. Okay. So when I have 2 to the third, I'm going to have 3 2's. 3 is my exponent that tells me how many times I'm going to repeat that base number. So when I look at the next one, I have 4 to the second power, which tells me I'm going to have 2 4's. So that tells me I'm going to multiply 4 by 4. Well, again, if I multiply it by 1, it doesn't change my value, but my answer is still 16. Now, if you have 2 to the 0 power, 2 to the 0 power, then when you have that 1 there, and you're going to have 0 2's. So that's why you're left with just the number 1. And it doesn't matter what that number is. Okay, if it was 5 to the 0 power, it's still going to be 1. If you have x to the 0 power, it's still going to be 1. So any number to the 0 power is always 1. All right, so I'm going to stop here for a sec, and we're going to go to our Kami, and I'm going to show you a few examples up here. Okay, sorry if you're hearing some of the background noise in the back. It says write the following using exponents. So if I actually gave you this number, okay, and I said I want you to write that using an exponent. Well, the base number is the number that's being multiplied. So the number that's being multiplied all the way across is 9. So that's your base number. That's your big number. And then how many times it appears is your exponent. So there's 1, 2, 3, 4, and 5. You have 5 9s across through there. So your 5 is your exponent. Okay, let's look at another one. Let's say we have 4 times 4 times 4. Remember, we don't use x as times anymore because that looks too close to a variable that we use. So we're going to either use dots or parentheses. So I could have used parentheses around all of these, and I would have been fine as well. Okay, so now your base number is 4. That's the number that is repeating. The exponent is how many times it repeats. Well, here we have 1, 2, 3. So I have 4 to the third power. Okay. Now, what if I have something that might contain a variable? Let's say we have x times x times x. Well, again, your base is whatever number it is that's repeating. In this case, it's a variable. So we have x. And how many times did it repeat? 3. So I would have had x to the third power. Now, sometimes I can have fractions. So I could have had 1/2 times 1/2. So the base number that is multiplying is 1/2, and it is multiplying 2 times. So I would put that in parentheses because if not, then your exponent would only hook to the top number. So when you have a fraction like that, if that exponent is going with both of them, which it is because they're both being multiplied by the same thing, then I would put them in parentheses. Okay? Now, what if my direction says write each power in expanded form? Expanded form means you're going to draw it out. Okay, so if I have 3 squared, remember your base is the number that's going to be multiplied, and 2 is telling me how many times I'm going to multiply it. So here, expanded form would look like 3 times 3. Okay, what if I have 5 to the 4th? That means 5 times 5, and I'm going to do that until I have 4 5s written down. Okay, so that's writing an exponent in expanded form. Now, sometimes we'll use the word evaluate or solve. That means I actually want to do all the math that I can, and I want to get one answer. So if I said evaluate 2 to the 4th, okay, I can just solve that. Now, if I need to expand it, let's say I'm going to multiply it by myself with no calculator, I might want to expand it first, multiply the first 2 numbers, so now that becomes 4. Then I would multiply it by the third number, and then I would multiply it by my 4th number, which is 16. Now, what a lot of people want to do is just go 2 times 4 is 8. Well, that's not your answer. Because remember, the exponent tells me how many times I'm going to multiply the base number. So I'm going to multiply 2 4 times. So 2 times 2 times 2 times 2. Okay? Now, sorry about that. If I'm having to use a calculator, okay, I'm going to scroll down. We're going to have the same number. So if we have 2 to the 4th, okay, on a calculator, sometimes you see a key that says X and then it has a little Y up top. That's using your exponents. So if I was to key this in on my calculator, I would put in 2 first because that's my base number. Then I would hit the key XY because that's going to tell me my next number is going to be the exponent. Then I would type in 4, and when I hit enter, it would give me the answer of 16. Okay? Now, you could always go 2 times 2 times 2 times 2, and you would still get 16. But if it's a very big number, sometimes it's hard to keep account of how many times you put that number in there. So sometimes it's easier to use this XY key. Now, another thing you can use is what we call a caret key. A caret key looks like an arrow that's pointing up. Okay, that's called a caret key. So if you use a caret key, you would plug in 2, and then you would hit that caret key, and it's going to say the next number following is an exponent, and I would put in 4. And again, that would give me my answer of 16. Okay, sometimes I may ask you when you have to write numbers out, maybe in Google Forms or something else that doesn't allow you to put the exponent as a small number. Sometimes I will ask you just to write that with a caret key. That way I know that you understand that that next number is your exponent. Okay, let's look at a fraction on that. Let's say we have 2/3 to the third power. Okay, well, if I expand that, that means 2/3 times 2/3 times 2/3. Now, if I multiply that, I'm going to go 2 times 2, which is 4, and 4 times 2 is 8. Okay? Then I would do the same on the bottom. 3 times 3, which is 9, times 3 is 27. Sorry about that. I'm going to clean that up just a little bit. So that would be 8 over 27. Okay? So those are some examples. You can go back and review those, pull the video back up, and let me explain those again some more if you need help. Otherwise, we're going to go back to our slides at this point and finish talking about our power of tens. Now, when we get into power of tens, okay, remember, okay, power of tens, okay, we're multiplying the base numbers still, okay, to get our answer. If it's positive, okay, so 10 squared would just mean we're going to go 10 times 10, and we can multiply it. Now, but there is a quicker way that we can get our answer there. So if we have 10 squared, again, like I said, we could expand. 10 times 10 is 100. The next one would be 10 to the 5th, which means that I'm going to multiply 10 5 times. So 10 times 10 times 10 times 10 times 10. And if you actually multiply it, it gives you 100,000. Now, here's the quick method for this. As long as your exponent is positive, it's going to tell you how many zeros to be used in the standard form. So if you notice, we had 10 squared, and there is 2 zeros, because remember, my exponent is going to tell me how many zeros. So I'm going to have 2 zeros. So when I go over here to write my number, after the 1, I'm just going to put in 2 zeros. So if you remember a minute ago when we multiplied 10 times 10, we got 100. Well, here, my 2 and my exponent tells me I'm going to have 2 zeros here as well. Let's look at the 10 to the 5th power. Well, we know 10 to the 5th power, it's going to have 5 zeros. 5 because of the exponent. And then here, when I write my number with 5 zeros, okay, that gave me the same answer as when I multiplied a minute ago. Here's the catch. It has to be a base number of 10. That doesn't work for other numbers. Okay, by adding zeros, that doesn't help us. It's only the base number of 10 that is able to do this. Okay, so again, how many zeros is determined by this exponent here. And then when you write, you're going to write that number of zeros down, and that is your answer. Now, let's talk about negative exponents. Okay, negative exponent makes the base number a reciprocal with a positive exponent. Reciprocal means you're going to flip the fraction. You can put any number, make it a fraction by putting it over 1. When you do the reciprocal, it's going to flip. So now 1 is going to be on top and the number you had is on the bottom. And it's going to lose the negative exponent and make it a positive exponent. So it's going to look like a fraction. And we're going to do some of these examples in a moment. Now, negative exponent does not make your answer negative. I see that a lot. That comes up on your SOL test, that your negative exponent, okay, they'll give you a false answer over there that looks like a negative number, but a negative exponent never makes your answer negative. A number with a negative exponent is always positive. So if it can't be negative, it has to be positive. So that's kind of a give me there. My next one, it says a number with a negative exponent falls between 0 and 1 on the number line. Well, if you think of the number line, okay, so we're 0, 1, 2, 3, 4, 5, and so forth to the right. If you go to the left after 0, you go to negative 1. And as we said a minute ago, a negative exponent never makes a negative number. So it can never go below 0. So if you think about it, a negative exponent can only fall between 0 and 1. Because if you have 10 to the 0 power, we know any number to the 0 power is always 1. So therefore, 10 to the 0 is 1, okay? Therefore, it has to fall between 0 and 1 because my next number down with that exponent would be a negative number. And it cannot be a negative number when I end up on the number line. A number with a negative exponent can be written as a decimal with one less zero than the exponent. So when it's negative, okay, the negative is going to make me think it's either a fraction or a decimal. If it's a decimal, it's got one less zero than the exponent. Whereas a minute ago, my positive told me exactly how many zeros I have. The negative tells me I have one less. And we're going to do some of those examples. So I'm going to exit back out of this and go back to Cami so we can work a few problems together. So here, if I have 10 to the negative 2, okay? Now, if I ask you to write that as a fraction using a positive exponent, remember, a negative exponent can be written as a reciprocal that ends up with a positive exponent. So the first thing I want to think about doing is making this a fraction by putting it over 1. I'm going to flip it. So now I get 1 over 10 squared. Now I have the reciprocal of that negative exponent. Now, if I ask you to expand this, that tells me that I have 2 of those. So I have 1 over 10 times 1 over 10 because I have 2 of those because that's my exponent right here. Now, if I multiply those, I can still multiply those. Well, we know 1 times 1 is 1, and 10 times 10, we know is 100. So I've got a fraction now, 1 over 100. Now, what if I wanted to make that a decimal? Well, remember, the negative says decimal, and I'm going to fill 2 spots, and my zeros is 1 less than that. So if my number was 2, I'm going to have 1 less 0, so that means I'm only going to have 1 0, and the second number is 1. So I have filled 2 spots. The last one has to be a 1, so I'm only going to fill in 1 0. Now, I will tell you, however, that a lot of times we like that 0 out in front of the decimal just so we don't lose sight of where that decimal goes. So, yes, there's 2 zeros, But when I talk about 1 less 0, it is after the decimal. All right, let's look at another one. Let's say we have 10 to the negative 5. So if I want to write that as a fraction and now flip it, I have 1 over 10 to the 5th. Now, if I want to expand that, I can, because that tells me I'm going to have 5 of them. So when I write it, I have 1 over 10 times 1 over 10, and I keep doing it until I have 5 of those. Sorry about that, guys. Okay, so I have 5 of these 1 over 10s. Now, if I multiply that, remember 10 times 10 times 10 times 10 times 10, 5 times has 5 zeros. So there is my fraction. Now, if I look at a decimal, remember the negative says I'm going to start with a decimal and I'm going to fill 5 spots. Okay, the last one has to be a 1, and I'm going to have 1 less number of zeros. So I'm going to have 4 zeros here. You can add that 1 0 out front, and therefore that is your answer for that one. Okay, let's look at one more example. Let's say we have 10 to the negative 3. If I want to write that as a reciprocal, I'm going to flip it, so 1 over 10 to the 3rd. Now I'm going to expand that. So I have 1 over 10 times 1 over 10 times 1 over 10. I have 3 of those. Now, if I multiply those together, I get 1 over 1,000 because I have 3 zeros there. If I want to create that as a decimal, your negative starts with a decimal. You're going to fill 3 spots. The last has to be a 1, and you're going to have 2 zeros. And again, you can put that 3rd zero out front if you, because of good mathematical looks. And so that's how I would write a power of 10 with negative exponents as a fraction, as an expanded form, and as a decimal. So in your homework, you're going to have some work that pertains to exponents, and you can use a calculator on those. Remember, you're either going to use your XY if you use it, or your caret key, or you can just multiply, get your answers. And then on the 2nd and 3rd sheet, you're going to have powers of 10, and you're going to just write them out like this. You're not going to use a calculator on those because they will not give you the same answer as what we've done. Okay, some of your calculators will come up with some errors, or it may show you a number with a negative exponent again, like 1e5. Okay, those get too confusing. Right now is all I want you to do is practice writing those negative exponents and positive ones in standard form, which is just a number, expanded form, expanding it out, and decimal form. Okay, if you guys have any questions, you guys can message, email, or get up with me during our Zoom meeting and ask any questions you might have.